Hello Longhorns, this is the Pre-Calculus AA Test 5.1 review. And so the first problem we're going to start with, number 1 here, says find each measurement. Well, they've given us 3 sides, so what we need to do is find the 3 angles for this triangle. And since this is an oblique triangle, we won't be able to use the Pythagorean theorem or right triangle trigonometry, so we're going to have to use the law of cosines. So we'll use the law of cosines to find one angle, and then once we have that one angle, we'll have a corresponding side with that angle, and then we can switch to law of cosines. So first, let's use the we can switch to the law of sines. Let's use the law of cosines first. All right, so the law of cosines says that cosine of angle A, we'll find angle A first. Cosine of angle A equals b squared plus c squared minus a squared over 2bc. So all we're going to do is plug those values in for a, b, and c, simplify that, and then we're going to find the cosine of alpha, and then we'll find alpha, we'll find angle A. Okay, notice that I have put all of the numbers in the numerator in parentheses and all of the numbers in the denominator in parentheses. That's to keep these calculations together, separated by the divide sign for our fraction. So just make sure that all of those values in your numerator are together, just use parentheses, and then also in the denominator use parentheses. That will keep your fraction together so that you're not getting odd calculations off the end of your fraction. All right, so we get that the cosine of alpha equals 0.8988. So now to find alpha, I need to do the inverse. So we're going to do cosine inverse, and we'll switch alpha with the number, and we'll find out what alpha is. Okay, so if we have our calculator in radian mode, we're going to get 0.4538 radians. If you have your calculator in degree mode, you would get the degree answer. But if your calculator's in radians, now you need to multiply your radians by 180 over pi, and that'll give you the degrees. So don't forget, multiply by 180 over pi, and that'll give you the degrees. Now, if your calculator's already in degree mode, then you're going to get the degree answer, which is approximately 26 degrees. So we know that angle A is approximately 26 degrees. So now with that information, I can go ahead and try to find the other 2 angles, but now I can use the law of sines. You only need to use the law of cosines once, just one time enough to get a corresponding side with its angle, and then you can switch to law of sines, which is a little bit easier. So now I'm going to switch to the law of sines to find my next angle. I'm going to choose angle B. All right, so for the next angle, angle B, I'm using sine B over side B, which is 6, equals sine of A, which is 26 degrees, over side A, which is 9. Now I'm just going to cross multiply and then solve for sine B. All right, so as you can see on this problem right here, I've cross multiplied this 6 times sine of 26 degrees divided by 9. And what we get, the result we get here is 0.2922. Well, that's the sine of B. So now what I need to do to get the angle is do sine inverse. So sine inverse, switch these 2 around. I get sine inverse of 0.2922 equals B, which is about 0.2965 radians. Now this is radians. So I'm going to put radians right here. Okay, that's radians. And so if you get your answer in radians, then you're going to want to multiply times 180 over pi to get the degree. So if your calculator's in degree mode, then you're already going to get the degree. And what you get is that B is approximately 17 degrees. Okay, so now we've got that A is 26 degrees, B is 17 degrees. Now to get C, it's pretty easy. We just need to subtract 26 and 17 from 180. And we get 137. So angle C is 137 degrees. Now we have all 6 of our measurements. So what we're going to do is we're going to list them off to the side so that you have all of your measurements listed, all 6 measurements. All right, so what we've got is angle A is 26 degrees, angle B is 17 degrees, angle C is 137 degrees, Side A is 9. That's the side opposite of angle A, 9. Side B is 6, and side C is 14. So this is the way you'll list your answers. All right, in problem 2, we're trying to find side C. So the first thing I'm going to do is label my triangle so I know where all my sides are. Side C is on this side of the triangle across from C. Side A is 18, and side B, we don't know what side B is. So, we don't need to know what side B is. We already know that we have angle A with its corresponding side, so we can use the law of sines. And we're looking for side C, but we don't have angle C. Well, angle C is easy enough to get. We just need to subtract from 180. Okay, so when we subtract 102 and 33 from 180, we get 45 degrees. So angle C is 45 degrees. Now I'm going to use the law of sines. All right, so I get, when I cross multiply this, I get 18 times the sine of 45 degrees divided by the sine of 102 degrees. Don't forget to push the sine button here. This is sine of 45 degrees, sine of 102. Make sure you're using your sine button. The answer we get is that side C is about 13 units. And since we don't have a measurement, we're just going to use the word units. And that would be our final answer for number 2. All right, in problem 3, we have to solve 2 triangles in order to find x. So the first triangle we're going to work on is this triangle right here. We're going to work on this one. And we can find this side by using tangent, because we know that tangent is side opposite the angle over the adjacent side. So opposite over adjacent. And since this is a right triangle, I can use right triangle trigonometry. So that's what I'm going to do. I'm going to use TOA from SOHCAHTOA. And I'm going to find the measurement for the height of my triangle. All right, so I know that the tangent of 32 degrees is the height over 34. And then I'm going to cross multiply this. So 34 times the tangent of 32 degrees. Put this in the calculator, I get 21 units. So the height of my triangle is 21 units. Now I can use that information and use tangent again to find this length right here for x. All right, so you can see here that we've used tangent again, because if I look at this angle right here, 66, this is the side opposite. The 21 would be the side adjacent, and again I can use tangent. So I used tangent again, and I said tangent of 66 degrees equals side opposite, which is my x, over side adjacent, which is 21. So I cross multiply and I get that 21 times tangent of 66 degrees is 47 units. So x equals 47 units. All right, so for problem 4, we're using Heron's formula to find the area of the triangle with side lengths of 12, 9, and 5. So the first thing we're going to do is write down our formula, and then we're just going to plug the numbers in and solve. All right, so for this one, we're actually working with 2 formulas. This is the primary formula that we're going to use to find the area. This right here, it's the square root of s times s minus a times s minus b times s minus c, where s is a plus b plus c divided by 2. So really we need to find this value first. We need to find the value of s first, and then we can plug s and a and b and c into this formula here and get our answer. All right, so when we plug in our value, 12 plus 9 plus 5 divided by 2, that equals 13. So we know that s is 13. Then we plug that value 13 into this formula here. So 13 times 13 minus 12 times 13 minus 9 times 13 minus 5. Take the square root of that, and we get 20.39 meters squared. Don't forget to put your units at the end of your answer. And then just put a box around your answer, and that's it for number 4. All right, for this problem, number 5, we're going to determine the number of triangles that can be formed. If the angle A is 48 degrees, side B is 10, and side A is 8. So we need to make some comparisons, but the first thing we need to do is we need to find the height of this triangle. So we know that h is, we know that the height of the triangle is going to be the side adjacent to the angle times the sine of the angle. That's going to give us the height. Okay, so this gives us about 7.4 units. 10 times the sine of 48 degrees is approximately 7.4 units. Now we're going to use that value to compare our values for A and B to that to see what kind and how many triangles we're going to have. Okay, since side A is 8, which is larger than the height, but smaller than side B, we actually have two triangles that are formed in this case, because we have this oblique triangle and we also have this acute triangle. So when this happens, we actually get two triangles formed. We get one here, and then the other one is this bigger triangle here. That's two triangles. So two triangles are formed in this case. So if A is less than B but bigger than the height, then we get two triangles formed. So the answer would be two triangles. Okay, for problem 6, find the area of the following segment. We need a couple other formulas. We need the area of a sector, and we need the area of a triangle. And what we're going to do is we're going to subtract the area of the triangle from the area of the sector to get the area of the segment. So let me write all those formulas down, and then we'll start plugging numbers in. Okay, so we're going to use the ratio that's created by our sector by using this angle measurement right here of 30 degrees. And we're going to divide that by 360. That's going to give us the ratio for this sector right here. And we're going to use that and multiply times the area of the entire circle, which is pi r squared. And then we're going to find the area of the triangle that's formed right here by using this formula, 1/2 AB sine of 30. Well, A and B are both 4 because we're using this radius as the sides of the triangle. So this side times this side, which is just 4 times 4, or 4 squared, times the sine of 30 degrees. And once we have those two measurements, we're just going to subtract the second measurement from the first measurement, and that's going to give us this area of a sector. All right, so 30 divided by 360 times pi 4 squared gave me 4.18 centimeters squared. 1/2 of 4 squared times the sine of 30 degrees gave me 4 centimeters squared. So when I subtract 4.18 centimeters squared minus 4 centimeters squared, I get 0.18 centimeters squared. And that's going to be the area of this segment right here. All right, for problem number 7, we're going to change tangent to cosine. So let's just go ahead and change this tangent to cosine. You could also do one with sine, just so you know how to do both formulas, because you'll get one of them on the test depending on which test you get. So we're going to do an example of cosine on this one. So what you want to do with the sum or difference formula is you want to find either two angles that add together to give you 195, or that you can subtract to get 195. So I'm going to find two angles. It doesn't matter which two angles you use, except they should be angles that are on your unit circle. So look for two angles on your unit circle that will add or subtract to give you 195. So for this one, I chose angles 150 and 45 because both of those are on my unit circle, and I can use values from those to find this solution. So I'm going to use cosine of 150 plus 45. That would give me 195. And now I'm going to use the sum or difference formula to rewrite this expression and find my exact answer. Okay, so here I have cosine of 150 plus 45. Cosine of 150 times cosine of 45 minus, now remember for cosine, the signs change. So you need to pay very close attention to which formula you're using and what the signs are doing. Okay, like plus or minus. So this one changes to a minus sign. Sine of 150 times sine of 45. So we go to our unit circle, we find these values, and we simplify. All right, so I looked at my unit circle, and I got negative root 3 over 2 for cosine of 150, root 2 over 2 for cosine of 45, 1/2 for sine of 150, and root 2 over 2 for sine of 45. Then I just multiply these together. I get negative root 6 over 4 minus root 2 over 4, and that gives me my final answer of negative root 6 minus root 2 over 4. All right, for problem number 8, we're just simply rewriting this expression so that it's expressed as one angle. And this is really simple since this is a sine cosine plus a sine cosine. It's very easy to combine these. Since we're using the sum and difference formula for sines, we're going to be using sine of alpha plus beta. So we're going to go ahead and write that down. All right, this is very simple. All you're doing is combining these two angles together. Since this is a law, the law that we're using here is for sine, we're going to keep our addition. So the sign does not change here. So we're doing sine of 22 degrees plus 43 degrees. 22 plus 43 is 65. So your answer is sine of 65 degrees. That's it. All right, in problem number 9, we're finding the 6 trig functions. If cosecant of theta is negative 5/4 and cosine is greater than 0. So in this case, we need to determine where cosecant is negative 5/4. Which quadrant are we in? So one of the hints that we get is that cosine is greater than 0. Well, cosine is the x value, so we're looking where x values are greater than 0. Well, that's going to be in quadrant 1 or 4. So we're not even going to be using quadrants 2 or 3, so we can just scratch those out. So we're just going to scratch those out, and we're only going to be using quadrant 1 or 2. Well, since our cosecant of theta is negative, we know that we're going to have to be in quadrant 4, because in quadrant 1, everything is positive. So we're also not using quadrant 1. So we know that our triangle now is going to be in quadrant 4. So we just need to determine which values are which. So cosecant is the same thing as hypotenuse over opposite. So hypotenuse over opposite. So we know that our hypotenuse is going to be 5, and our side opposite the angle, which is this side right here, will be negative 4. And we know that our hypotenuse is 5. So you would have to use the Pythagorean theorem then to find the third side, which we know this is a Pythagorean triple, so that's going to be 3. You can use the Pythagorean theorem, scratch work on the side, or whatever you got to do if you don't know that, if you don't recognize that as a Pythagorean triple. Okay. Now we're going to use those 3 sides to write out our 6 trigonometric functions. So we know that the sine of alpha is the reciprocal of the cosecant. We know that the cosecant was negative 5/4, which makes our sine negative 4/5 since it's the reciprocal. And we can also see that on our triangle, side opposite over hypotenuse. So negative 4/5 is sine. Cosine is going to be adjacent over hypotenuse, so that's going to be 3/5, and it's positive. Tangent is negative in quadrant 4, so tangent is going to be opposite over adjacent, which would be negative 4/3. And secant is the reciprocal of cosine, so it's going to be 5/3. And cotangent is the reciprocal of tangent, so negative 3/4. And that is those are our 6 trig functions for this triangle. So the trick to these is to find out which quadrant you're in, and then draw your triangle from there and make sure that you have your sides correct. So make sure that you're checking all of your hints from the information that you're given. All right, so for problem 10, we are verifying the following trigonometric identities. Okay, so for the verifying problems, we're not going to give you one that does not verify. So please do not give me an answer that says false or not true or something like that, because we are not going to give you one that does not verify. We want you to be able to verify it. So it is true, it is going to verify. So please, I don't want to see any answers on the test that say not true or can't verify, because that's wrong and you're going to get the problem wrong, okay? All right, in order to verify this identity, I am going to change tangent into sine over cosine, which I've done right here. So I've taken this tangent and I've rewritten it as sine over cosine. Then I take this cosecant and I rewrite it as 1 over sine using my trigonometric identities. Now once I've done that, I can go ahead and cross out these signs. So I'm going to cross them out. They cancel out and I'm left with 1 over cosine alpha. Well, if I look at my identities, I know that 1 over cosine alpha is the same thing as secant alpha, and it's verified. Now for problem B, this one's a little more complicated because we have a little more going on. So I'm going to go ahead and break this out. All right, so notice that I'm only working with one side of my equation. I'm going to leave sine alpha alone. I'm not going to do anything with that. Okay, I'm not doing anything with this. I'm trying to prove that this side is the equivalent to this. So the way I'm going to do that is I'm going to go ahead and change these into terms of sine and cosine. So cosecant is 1 over sine alpha. Then I have my minus sign. Then cotangent is cosine over sine. And then I'm just going to leave this cosine as a cosine over 1. Then I'm going to simplify this. All right, so what I've done here is I have multiplied these two cosine alphas together to get cosine squared alpha. So in the numerator, I have 1 minus cosine squared alpha. And in the denominator, I have sine alpha. So this has a common denominator, so I'm just going to keep the common denominator. Now I look at my Pythagorean identities, and I see that 1 minus cosine squared alpha is the same thing as sine squared alpha. All right, so I get sine squared alpha over sine alpha. Well, I can cancel out one of the signs. So what I end up with, after I cancel out one of the signs, is just sine alpha, which is what I was trying to prove. And I've proven it. Also keep in mind on the test, you shouldn't need more than 1 or 2 steps. I only used 2 steps basically to simplify this. If you are doing these and you get this big giant problem where you're making all kinds of changes and you have multiple steps, you've probably gone down the wrong path. So try to keep it simple. It should be only 1 or 2 steps, not many steps. If you're taking many steps to simplify these, then you've gone the wrong way and you need to go back and erase and try something else. For problem number 11, you're going to find all solutions to the equation on the interval. So you're going to look for values on your unit circle between 0 and 2 pi for the solutions for these equations. So what we're going to do is we're going to solve these equations, and then we're going to look on our unit circle to see where that value exists. All right, so for this first equation, first we add 2 to both sides of the equal sign, and we get 4 sine alpha equals 2. Then we divide by 4, and we get sine alpha equals 2/4 or 1/2. And then we look at our unit circle to see where is sine 1/2. And so we find that the sine of the angle is 1/2 when the angle is pi over 6 and 5 pi over 6. Those are the 2 places on the unit circle where the sine of the angle is 1/2. All right, B is very similar to A. We have 2 cosine alpha equals 1 because we add 1 to both sides, and then we divide by 2. We get cosine alpha equals 1/2. Again, you're going to look at your unit circle to see where on my unit circle is cosine equal to positive 1/2. And that happens at pi over 3 and 5 pi over 3. So those would be your two angles where the cosine is 1/2. The last problem, 3 tangent squared alpha minus 1 equals 0. We're going to go ahead and solve this one. Okay, for this one we have 3 tangent squared alpha equals 1. We added 1 to both sides. Then we divided by 3, so we've got tangent squared alpha equals 1/3. Then we have to take the square root of both sides. So we take the square root of this, we get tangent alpha equals the square root of 1/3. We have to rationalize the denominator and rewrite this as root 3 over 3. So we're looking where tangent of alpha is root 3 over 3 on our unit circle. That happens in 2 places, at pi over 6 and 7 pi over 6. And that's it. Okay, so that's the end of the review for test 2, or test 5.1. Just make sure that you know how to find all your measurements on your unit circle, that you know where the equations and the formulas that you're going to need are located on your formula chart. Make sure you practice enough problems that you feel comfortable and confident for the test on Tuesday. So good luck, Longhorns.